Find in the form AI add bj a vector whose magnitude is twice the magnitude of the vector 2i add j, and which is parallel to the vector 6i minus 12j. Well, let's compute a vector whose at least the magnitude of the vector which is twice the magnitude of 2i add j. So the magnitude of 2i add j is simply a square root 2 squared add 1 squared, which is square root of 5. And we have twice that as the magnitude of the vector. We have that as 2 times magnitude 2i add j, which is 2 times root 5, which is 2 root 5. Right, so that's the magnitude of the vector that we're trying to find in the form ai add bj. The direction vector we'll call it F. So force, we'll call it a force, is D, which we're given as 6i minus 12j. So we can find a unit vector in this direction, and that's the magnitude D divided by, the vector divided by the magnitude of D, which is equal to 1 over 6 root 5 brackets 6i minus 12j. Again, I've found the modulus or the magnitude of this vector by squaring 6 and adding it to the square of minus 12, and that computes to give us 6 root 5. We've turned it into a fraction to multiply our vector d by 1 over 6 root 5. But we know that f is equal to the magnitude of f, which we found as 2 root 5 times d hat. And this is equal to 2 root 5 brackets 1 over 6 root 5 brackets 6i minus 12j. By the way, I forgot to mention that if one vector is parallel to the other vector, that implies that the vectors are in the same direction. So here it says this vector 2i add j, which is parallel to the vector 6i minus 12j. And that's how we'll be able to apply this relationship, because it's in the same direction. And this evaluates to give us 2i minus 4j. So make sure this is on the screen. 2i 4j. If you're not clear about what these formulas are about, please look at my previous videos. I've explained them in detail. Thanks for watching. I'm Alistair.